get started on 2-4 example 4, we need to review the different forms of a line. Hopefully you can remember slope-intercept form. You learned this back in middle school and hopefully can still recall. Intercept form is y equals mx plus b, where m was your slope and b was your y-intercept. A little arrow. The second form of a line that you should be able to remember and use is point-slope form. You should have learned this last year in algebra. Y minus y1 equals m times the quantity x minus x1. And I'm going to plug in some different colors here because I want you to remember that that's what we're plugging into this. So y1 and m and x1, where m is your slope and x1, y1 is a given point. And then we had good old standard form. And standard form came as ax plus by equals c, where c is a constant. We're going to be using point-slope form quite a bit in being able to compare parallel and perpendicular lines. And actually, this is something you should have learned last year in algebra and be a fairly quick review this year. In example 4, they've given us a line, and they want to say, what is the equation of the line through P that is parallel to L? Well, we need to identify the slope of L. In this particular picture, they have given us the equation, so we can just identify the slope right here as 1/2. So the slope for L is 1/2. If we're talking about parallel, then we know that our new line has to have the same slope. So our slope for P will be 1/2 also. So we know that those are our m values, right? This is equals m equals m. Okay, so we're going to use point-slope form because we have a point and we have a slope. We need to be able to fill that in. So we're going to start by saying y minus and leave the x minus. And the reason when I showed you this form before, I left those in different colors is because those are the pieces we fill in. So we're going to go ahead and fill in our slope. We know that is 1/2. And then we have a point for 1. So this is our x1 and this is our y1. So we can just plug those in. Y is 1 and x is 4. And technically speaking, we are done. This is an equation in point-slope form. If we wanted this in slope-intercept form, like this one, they gave us in slope-intercept form, then we could go ahead and solve for y. and then it would be in y equals mx plus b form. But we do not have to solve this at this point because it didn't specify which kind of formula we were looking at. Just so that those of you who would like a reminder can see how it would work, let's go ahead and use the distributive property here. Y minus 1 equals 1/2 x, and then 1/2 times -4 is a -2, and then I would add 1 to both sides of the equation, and I would have this as my answer. Y equals 1/2 x minus 1. This is also a perfectly acceptable answer right here. We could have been done right here. On part B, our example part B, this is what is the equation through the line that is perpendicular to L. So we're going to use line L. It had a slope of 1/2, if you recall. The perpendicular slope takes that 1/2 and flips it upside down, so we have 2/1, and this was positive and this becomes negative, and so that simplifies to a -2. Now that we know our perpendicular slope, we're still going to use P, which, let's go ahead and write down that point P was at 4, 1. And so now we're going to use that point slope form again, and we're going to plug into point slope form. We have our y minus and our equals and our x minus, and we're plugging in our new slope, which our new slope was -2, and our point that we're plugging in was 1, 4. Could we stop there? Yes, we could. We could say, this is our answer. Or we could solve that into slope-intercept form by using the distributive property. And getting -2x plus 8, and then adding 1 to both sides. And this would be our answer. So either one of those is perfectly acceptable. They are just different forms of the equation. Either way, you're going to want to start with point slope form to get it into the correct formula. Go ahead, pause your video and do the try it. They gave you an equation. They want you to find lines that are parallel and perpendicular to the original. So hopefully you paused your video and you came back to check. So if you had parallel, your slope should have been -3, and your point with your x1, y1 right there is the 3 and the -1. So you should have written out your equation, and then you should have plugged in -3. You should have plugged in 3 and 1, and you could have left it there. If you wanted to solve it into slope-intercept form, you would have, so this is an answer. You could have also said y equals -3x plus 10. So if you went that far, you can do that. Let's go ahead and look at perpendicular. The slope would have changed from -3 to be positive 1/3. So we would have written out our formula. And we would have plugged in for the slope I don't know why my pen is really having a hard time tonight. We would have plugged in for the slope 1/3. And for the point, we're still plugging in the 1 and the 3. And we could have left it like that. Or if you solved, this would have actually come out to be y equals 1/3 x. And your C value would be gone. On part B, your parallel lines. Here was our slope. Here was our x1, and this is our y1. We're going to take our formula. We're going to say y minus and x minus. We're plugging in 3/4, and we're plugging in 12. And when we plug in the -2, we would have minus a -2, which makes it a +2. So this would have been perfectly acceptable to leave it like this. If you went all the way to slope-intercept form, you would have had y equals 3/4 x minus 11. And this is your parallel. And for perpendicular, you would have written out your equation. Y minus and x minus. And our slope would be an opposite reciprocal. So instead of 3/4, we would have -4/3. And then our point would still be 12, and it would still be a +2. So that would have been perfectly acceptable to leave it in point slope form. If it asked for slope-intercept form, you solve it, and you would have gotten y equals -4/3 x plus 14.